Okay, so this is another basic drug dosage calculation, but in this case we are not working with a liquid drug. We are working with a drug in tablet form, as you can see by the supply. So we have a patient that weighs 30 pounds. We have a dose. We want to give 10 milligrams of the drug for every 1 kilogram of body weight. So again, you'll notice that the units of measurement here do not match. We're going to have to change the patient weight from pounds into kilograms. And then we have tablets where 1 tablet is equivalent to 40 milligrams of the drug. So this is a basic tablet dosage conversion problem based on the weight of the patient, and the steps are very straightforward. So if you want, you can also think of this as, 1 tab per 40 milligrams, something like that, or 40 milligrams per tab if you want to think of it in terms of ratio form. Right? What we're basically saying here is 1 tablet is equal to 40 milligrams of the drug. So you can, in fact, write that as a conversion ratio. So let's go ahead and do this problem out. So we have a 30-pound animal. And the first thing we need to do is get out of pounds and into kilograms, because the drug dosage in this case is in kilograms. And we know that 1 kilogram is 2.2 pounds. You're going to be dividing by 2.2 a lot. Anytime you have pounds to kilograms, this little conversion here is your friend. All right, so we are out of pounds and we're into kilograms. So I would know what the patient weighs in kilograms, but the next step here is to figure out how much of the drug to give in terms of milligrams. So I'm going to use the dose information to change from kilograms to milligrams. So if I were to stop here, this would tell me how many milligrams of the drug to give, but I need to give it in tablet form. So what I'm going to do is, again, I want to get out of milligrams and into my final form, which is tablets. And I know that 1 tablet is 40 milligrams. So there's milligrams gone, and I'm left in the unit of measurement that I want, which is tablets. So now everything else is just multiplication and division. So what's left in my numerator? I've got a factor of 30 and a factor of 10. In my denominator, I've got a factor of 2.2 and a factor of 40. And this is going to be tablets. So that's 300 in my numerator. And this should be 88 in my denominator. Let's just double check, because it never hurts to use a calculator for things like this. And when you take 300 and divide it by 88, you come up with a value of 3.409909, et cetera, et cetera, et cetera. Now, typically, we round these to the nearest half a tablet. So what we're going to do is basically look at the first few numbers here in the expression. And if I were to round this, I'm going to go over here to the left. This would round to approximately 3.41 tablets. Now, of course, you can't give 0.41 tablets. It's impossible to split a tablet into 41/100ths. So this is why we go with the nearest half a tablet. So 3.41 is between 3.0 and 3.5. So 3.0 is the nearest half tablet below 3.41. 3.5 is the nearest half tablet above. And 3.5 is closer to 3.41. So our final answer, for the purposes of this exercise, would be 3.5 tablets.